Okay, we're going to talk about side, 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 and side angle side proofs again today. We are going to be able to figure out if these triangles are congruent just based off of how they're marked. So on number 1, if you look at the way these triangles are marked, you've got two sides marked and you've got an angle marked. And you know that this angle is where the sides intersect at. So this angle is in between the two sides. So that meets the criteria for side angle side, because the angle must be in between the two sides. So if you look at this is going to be side angle side, and then you'll be able to write a congruency statement based off of those angles. So if you start with your congruency statement for the left-hand triangle, you're going to say triangle YQT. You can put those letters in any order to begin with. You're going to set that congruent. You've got to get the order right in the second triangle. So you know that Y had one curve around it, and it was the one that we put in the first place. So we want to start with the one curve around that angle K. We want to start with angle K. So then in the first triangle, we went from Y to Q. So we moved along this side that has one line through it. So if we do that in the second triangle, we're going from K, we're moving along the side that has one line through it, and we'll get to C. So then the last letter that I have is P. So if we look at number 2, the only side that is not marked here is AC. So we're going to put 3 lines through it. It's congruent to itself because it's the side that the triangles share. So I have 3 sides marked here. So this is going to be side, side, side. And then I'm going to write the congruency statement here. So if I write the congruency statement, I'm going to start with this left-hand triangle. I'm going to say triangle ADC. That is going to be congruent to the triangle. If I look at A is in between the sides that have one line and 3 lines through them. So if I look for the angle over here on the right-hand side that is in between the side that has one line and 3 lines, that's going to be angle C. So that's the one I have to start with. So then I moved from A to D. So I moved along the side that had one line through it to get to D. So that's what I'm going to do over here. I'm going to start with C. I'm going to move along the side that has one line through it, and that will lead me to B. So then the last letter that I have left on the right-hand side would be A. So if we look at number 3, we've got overlapping triangles here. We have this triangle JMK, and we have this triangle LMK. The side that they have in common is this MK. So once we mark that congruent, because it's congruent in both triangles because it's a shared side, we have a side, we have an angle, and then we have a side. So this is side angle side. So then if I write my congruency statement, I'm going to start with this triangle here. I'm going to start with triangle JMK. That would be congruent. J is up here at the top on this line that has one line through it. So if I follow that one line here, I'll get to angle L. I know M is marked congruent to K, so since I had M next, I'm going to put K here because M and K are congruent. And then I also know that K is congruent to M, so I'm going to put M as my last letter here. Okay, so earlier we talked about the side angle side criteria being that the angle had to be in between the two sides. So on number 4, if you look, these angles, they're not in between the two sides. The angle that are in between these two sides would be this angle S, and it's not marked. So you're going to put no here. So there won't be a congruency statement because these are not congruent triangles. So you're putting no here because the angles aren't in between the sides. Okay. So number 5, the side that we would mark congruent here, the only side left over, is EF. So it's congruent in both triangles. So this would be a side-side-side triangle. And if you wrote your congruency statement here, you would say triangle CEF will be congruent to the triangle. You would have to put it in the order, the triangle DEF. Okay, so on number 6, you've got these little arrows here, which show you that you've got parallel lines. So you can use alternate interior angles here. So if you put a curve around the angle that is in between these two sides, these sides will intersect at D, and these sides will intersect at E. And those are alternate interior angles, so we can mark them congruent. So we have a side, an angle, and a side. And then you can write your congruency statement. So if you start your first triangle as DAJ, your second triangle would have to be in the order EAM. Okay, number 7. The angle does not fall in between the two sides, so this does not work. On number 8, the angles that are in between these two sides are your vertical angles. So this works by side angle side. And you can write your congruency statement. You could say triangle ACB is congruent to your triangle ECD. Okay, so on your proofs here, you're going to start with your given statements. You can see that you've got 3 given statements. So those will be the first 3 statements, and your first 3 reasons will all be because they're given. So go ahead and jot those down. And then you'll mark them in your picture with 1 line through them. Those are parallel, so I'm going to put an arrow through them. And then the very last statement will always be what you want to prove. So number 6 is going to be triangle ABD is congruent to your triangle CDE. So if we look at number 3, it uses the word midpoint. So you automatically know that your next reason is going to be definition of midpoint. So because D is the midpoint of this segment, we know that either side of that segment is congruent. So that's going to be your number 4 statement. You're going to say that BD is congruent to DE. So because you've got parallel lines involved here, that means that you can use either alternate interior, exterior, or corresponding angles. So you can use an angle here. The angle that would be between these two sides, where these two sides meet up, would be angle B, and the angle in between these two sides would be angle D. So we want to write down that these two are congruent to each other. So I've got to use 3 letters to name these sides. I would name this side ABD, making sure that B is the angle in the middle of those letters. So I'm going to say angle ABD is congruent to this angle here. I'm going to use 3 letters, so I'm going to use CDE. So those kinds of angles here on these parallel lines, when they're in the same position and on the same side, they are called corresponding angles. So based off of what I have marked here, I have a side, I have an angle, and a side. So I proved that these triangles were congruent by side, angle, side. Alright, so moving on to the next proof. If you look at number 10, you've got two given statements. So if you jot those down, you have Km is congruent to Nm. That's given, and I'm going to mark it in my picture with one line. I have Lk is congruent to Ln. That's given. And I'm going to mark it with two lines. I want to prove that the triangle LKM is congruent to the triangle LNM. So what I'm going to do is, with my picture, the way that I have it marked, I have two sides marked. The only side that I don't have marked is LM. And I know that it's a shared side between the triangles. So when it's a shared side, you can say that it's congruent to itself. So you can say on line 3 that LM is congruent to LM. When a segment is congruent to itself, this is called reflexive property. So based off of what I have marked in my picture, I have all three sides marked. This is side, side, side. So if you look at number 11, you've got two givens. So let those be your first two statements. And it's already marked in my picture. So then I have AC bisects angle DAB. That's given. And then what I wanted to prove is that the triangle ADC was congruent to the triangle ABC. So I know with side, 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 it only deals with sides. But on this one, I know that I'm going to deal with an angle here because I have angle DAB. So I automatically know that my last reason is going to be side angle side because I have angles involved. So if I see that word bisects, I automatically know that my next reason will be definition of angle bisector. So I just need to look at what angle was being bisected. So angle DAB, this angle is being cut in half so that each part is congruent. So if I write these angles down, I'm going to say that angle DAC, the angle on the left, is going to be congruent to the angle on the right. I'm going to call it CAB. So that's congruent to CAB. So then if I know that I'm going to have to use side angle side, I need to use the side that will put the angle in the middle. So if I use this side, that will place the angle in the middle of the two sides that I have marked. So I have to say that AC is going to be congruent to itself, AC. So again, that is my reflexive property. Okay, so the last proof here, you've got two givens. So you're going to use JM is congruent to MN. So that's given. And then I'm going to mark it in my picture. And then L is the midpoint of JN. So that's given as well. My last statement will be what I want to prove. So if I see the word midpoint, I've got to use definition of midpoint for my next reason. So because of that midpoint being L, it's putting J in to where it is being cut in half. So I know that JL and LN are going to be congruent because of that midpoint, L. So then the only side that I don't have marked is the side that they share. And I can always say that the side that they share is congruent to itself. And this is called my reflexive property. So then what I have marked in my picture is side, side, side. Okay, so on the very last problem here, if you're using coordinates and you're trying to find the length of each side, you have to use your distance formula. So you're going to use x2 minus x1 squared plus y2 minus y1 squared, all under the square root. So you're going to use that on every single set of coordinates here. So you're going to use that distance formula 6 times total. So it's telling you in each box which 2 points to use. And if you end up with 3 sets of matching sides here, that means that you have a congruent triangle. So we're going to go ahead and plug in PQ, 5, negative 4, and negative 3, 7 into our distance formula. So if I plug that in, I'm going to take negative 3 minus 5 squared plus 7 minus a negative 4, which will turn into a positive squared. And if I plug that in, I get a total of 185 under my square root. So with QR, I'm going to take negative 3, 7, and 0, 2, and plug it into my distance formula. I'm going to take 0 minus a negative 3 turns to a positive 3, plus 2 minus 7 squared. So if I plug that in, I get 34. And then with PR, I'm going to plug in 5, negative 4, and 0, 2. So if I plug that in, I'm going to get 0 minus 5 squared, plus 2 minus a negative 4 squared, which will turn into a positive. So you get 61 here. So with XY, you're going to plug in negative 2, negative 1, and 9, 7. So if we plug that into our distance formula, we're going to take 9 minus a negative 2, which will turn into a positive, squared, plus 7 minus a negative 1, which will turn into a positive squared. And you're going to get a total of 185 here. So for YZ, you're using 9, 7, and 3, 2. Plugging it into your distance formula. You're going to take 3 minus 9 squared plus 2 minus 7 squared. So if you plug that in, you're going to get 61. So you know so far that XY and PQ are matching up with their numbers. You know that YZ and PR are matching up with their numbers. So let's double check. Let's make sure that this one will match up with QR. So we're going to take negative 2, negative 1, and 3, 2. So if we plug that in, we're going to take 3 plus 2 squared plus 2 plus 1 squared. My signs changed because I had 2 negatives. So I'm going to get 34. So this does match up with QR. So it asked me if the triangles are congruent. My answer is yes, because I have 3 sets of congruent sides. So if I explain my reasoning, I'm going to write down those 3 sets of congruent sides. I'm going to say that PQ is congruent to XY. I'm going to say that QR is congruent to XZ. And I'm going to say that PR is congruent to YZ. So I'm going to let that be my congruency statement. So that is also how you work number 2. If you do not get a set of matching points on each one of them, if you don't have 3 sets of congruent sides, then your answer would be no right here. And that's it.